All right, today we're going to talk about factoring polynomials, section R4, the very first lesson of this course. The objectives for this lesson include number 1, factoring out the greatest common factor, number 2, factoring by grouping, number 3, factoring trinomials, then we'll factor binomials, and then factoring by substitution. Guys, I'm going to tell you right now that factoring is one of the most important concepts in algebra. We're going to see it time and time again. And if you go on and take future math classes, you're going to see how important factoring really is. So pay close attention to this, and if you struggle with this later on in the semester or another course, come back to this video, let's watch again, and just watch some general factoring. The best way to learn how to factor is practice, practice, practice. So let's start off with the first thing with factoring. We're going to do greatest common factor. When factoring, I don't care what kind of factoring you're doing. When factoring, you must always, always, always check for a greatest common factor first. Then ask yourself, can I factor further? So these first few problems, we're going to look at just factoring out the greatest common factor. So letter A here says 9y to the 5th power plus y squared. So here we see two terms. And remember, terms are separated by either adding or subtracting. So in this case, I have a term of 9y to the 5th power, and I have another term of y squared. So in factoring, you want to look at each individual component of each term. So in the first term, I have a 9 times y to the 5th power, and the second term is just y squared. So looking at the coefficients, I have a 9 and a 1. Well, the biggest number that goes into both 9 and 1 is just 1. So I don't have to worry about taking any coefficients out. The second thing I want to look at is my y's. Well, my first term has a y to the 5th power, and the second term has a y squared. So both of these terms have a y. Not only do both terms have a y, both terms actually have, looking at the smallest exponent, which is 2, both terms actually have a y squared. So I can factor a y squared out of those two terms. So when you're factoring out something, you have to ask yourself, okay, if I factor that y squared out, what can I multiply y squared by to get back what I started with? And so if you think of this as division, it's going to help you out a lot. So I took a y squared out of 9y to the 5th. Well, if I just divide that, 9y to the 5th power divided by y squared. Well, 9 divided by 1 is just 9, so I still have a 9 there. And we're going to come back to talking about the rules for exponents in a little bit. But if I have y to the 5th power divided by y squared, I'm left with y cubed. What that means is 9y cubed times y squared will get me that 9y to the 5th power. So when I factor out that y squared, I'm left with y cubed. So y squared times 9y cubed gives me my 9y to the 5th back. Now, what do you have to multiply y squared by to get y squared? Well, they're both positive, so it's going to be a positive number. Y squared times what is y squared? And here's where I see a lot of errors come in math class when factoring. Think, well, if you take a y squared away, then there's nothing left, so it's a 0. Well, if I don't put anything there, then I can't multiply that y squared by something to get back my original problem. So if everything is gone, if everything's taken away, then I know that there has to be a 1 there, because y squared times 1 will get me that y squared back. And part A is now factored. Part B, sorry about this overlap here. I have 3 terms. I have 6x squared t, I have a positive 8xt, and I have a negative 12t. So again, terms are separated by adding or subtracting. Let's start off with the numbers. What number goes into 6, 8, and 12 evenly? Well, the only number that goes into 6 and 8 and 12 is 2. So I can factor out a 2. Now let's look at the variables. The first term has an x squared in it. The second term has an x in it. The third term does not have an x. Therefore, x is not common to all three terms, so we can't factor an x out. How about t's? Well, the first one has a t, the second one has a t, the third one has a t, so I can factor a t out of all three terms. And because all three terms have a t, I look at the exponent. Well, the smallest exponent on that t is 1, so I'm factoring out grand total 2t. So now we have to ask ourselves, what can we multiply that 2t by to get back my original trinomial of 6x squared t plus 8xt minus 12t? And again, we do that by division. So we'll do this one term at a time. Let's look at that first term. 6x squared t divided by 2t. Well, 6 divided by 2 is 3. X squared divided by, well, there's no x squares down there, so it's just 1. So x squared divided by x squared is, or x squared divided by 1 is x squared. And t divided by t would be 1. And there's no need to write that 1 down because I already have a 3x squared. So let's ask ourselves, is it true if I multiply 2t times the 3x squared, will I get 6x squared t? So let's see. 2 times 3, there's my 6. I have an x squared times 1 is just x squared. I have a t, t times 1. Okay, good. That will get me the 6x squared t. Let's go to the next term. 2 times what will get me that positive 8? Well, 2 times a positive 4 will give me a positive 8. And I need an x, so I'll write it down. And t, again, t divided by t is 1. Don't need to write that 1 down. Double check ourselves. 2t times 4x, that is 8xt. Last term. I have a negative 12t. So how do I take 2 times what number will give me that minus 12? Well, of course, 2 times a minus 6 is minus 12. And then t divided by t is 1. And folks, there it is. I have factored out a 2t. 2t was the greatest common factor. Part C steps it up a little bit. Here I only have 3 terms. And again, terms are separated by either adding or subtracting. If you'll notice, this first term is 14 times this m plus 1 to the third power. So that m plus 1 is one thing. It's a variable in itself. That's not 2 separate terms there. Even though there's a plus inside that m plus 1, the 14 is multiplied by m plus 1 cubed. Therefore, this is only one term. My second term is negative 28m plus 1 squared. And my third term is minus 7m plus 1. So looking at the first term, or the 3 terms, the coefficients. My coefficients are 14, negative 28, and 7. Well, the largest number that goes into 14, negative 28, and 7 is 7. So I can take a 7 out of all 3 of those terms. What else do those terms have in common? Well, the first term has an m plus 1 that's cubed. The second term has an m plus 1 that's squared. And the third term has an m plus 1, which means all 3 of those terms have an m plus 1. So now that I've taken that 7 away from all 3 terms, now that I've taken that m plus 1 away from all 3 terms, we can ask ourselves, what's left? So if I was to multiply that first term by 7 times m plus 1, 14 divided by 7 is 2. M plus 1 cubed divided by m plus 1 is going to be plus 1 squared, because 3 minus this coefficient, or this exponent of 1, 3 minus 1 is 2. So that's the first term. Second term, 7 times what is negative 28? Well, that would be a minus 4. M plus 1 squared divided by m plus 1. One of the m plus 1's cancels. 2 minus 1 is 1. So I am still left with an m plus 1. 7 times what is negative 7? Well, 7 times negative 1 is that minus 7. And m plus 1 divided by m plus 1 is just 1. It's gone. So I factored out the greatest common factor, which is 7 times m plus 1, and I'm left with 2 times m plus 1 squared minus 4 times m plus 1 minus 1. Moving right along. Factoring by grouping. This is another method of factoring. Factoring by grouping is something you want to look at if you're factoring some kind of a polynomial that has 4 or more terms. Okay, when a polynomial has more than 3 terms, that's what I said, 4 or more, it can sometimes be factored using factoring by grouping. So here are 4 polynomials, and what we're going to do is we're going to factor them by grouping. Okay, so the first polynomial, looking at it just as it sits, if I grouped that first group, I have an mp squared plus 7m. Well, I look at that and I notice that both of those terms have something in common. So what is the greatest common factor of mp squared plus 7m? Well, I can factor an m out of both of those. If I take an m out of those, I'm left with p squared. And you can see that m times p squared will give me mp squared plus 7, because m times 7 is 7m. So I have factored that first pair. The second pair is a positive 3p squared plus 21. Well, what do those two have in common? Well, they both have a number, 3 and 21, and 3 and 21 can both be divided by 3, so I can factor out a positive 3. If I factor a positive 3 out of that, 3 times p squared would give me 3p squared, and 3 times plus 7, 3 times 7 gets me that 21. So what I've done is I've taken 4 terms, I've grouped them, and now I have 2 terms. This is 1 term, and this is 1 term. Now, as I look at those 2 terms, I ask myself, okay, well, what do those 2 terms have in common? Well, both of those terms have a p squared minus plus 7 in common. So I'm going to write down p squared plus 7. And so looking at the video portion of this, you won't see this actually on the video screen part, but you can see in the lower right corner. If I factor out that p squared plus 7 and kind of think of it as I'm covering those 2 guys up, what do I have left? Well, I see an m is left, and I see that a 3 is left. So, sorry about that. I wrote on the board a little bit when I was putting my hands on it. Make those go away. Okay, so if I factored out that p squared plus 7, basically I have left this m, and I have this 3 left, so plus 3. And there you go. It's now factored. Okay? The second one, as I look at that, and I start to take the same approach, if I look at those first 2 terms, 2y squared and an az, man, there's nothing in common there. Look at the next terms, negative 2z minus ay, well, there's nothing in common there either. But if you remember in math, if you keep your terms, if you keep the signs on your numbers, arrange things and it's still going to be equal. So when I look at this, I see that there are 2 terms that have y squareds in them. But I also see 2 terms that have 2's in them. But I also see terms that have a's in it. And so there's lots of ways to look at this, to group it, but which way is going to be beneficial to us? Okay, well, let's look at somehow grouping it where we can take that first piece off. So if I put 2y squared minus 2z, so notice that I kept the signs together. That was a positive 2y squared, that's a negative 2z, so I kept it that way. And then I do minus a y squared plus a z. That's a z. I've written this in such a way that they kind of look like some patterns going on there. So let's try this and see what happens. 2y squared minus 2z. Well, as I look at that, I said, well, I can take away a 2 out of both of those. So if I factor a 2 out of 2y squared, I'm left with a y squared. And I factor a 2 out of a negative 2z, I'm left with just a minus z. Now let's factor the other pair. The other pair, I have a negative ay squared plus az. Now here's where it kind of gets tricky. Because that leading term, minus ay squared, because it's negative, and I look at both of these terms, they both have an a in it, I'm not factoring out an a. Because that first term is negative, I'm actually going to factor out a negative a. So factoring out a negative a from a negative ay squared leaves me with y squared. If I factor a negative a out of a positive az, I'm factoring out a negative 1 because negative 1 times negative a will give me that positive a. So I'm taking out a negative 1 and I'm leaving that z behind. I now have two terms. Both of those terms have something in common. I can factor a y squared minus z out of both of those terms. And if you visually think about it, and we're canceling, if you will, that y squared minus z, leaving behind a 2 minus a. And that is now factored. And part C. And folks, most of the time when you're given problems to factor by grouping, they're going to be set up already for you. Very rarely will you see a problem set up that you're going to have to actually think about it and rearrange them and put them in order and things like that, but it can happen. Part C. Part C looks very nice for us. So it's already set up, descending powers. We look at the first two terms, 4x cubed plus 2x squared. I can factor a 2 out of that. 2 goes into 4 and 2 goes into 2. They both have x's in them, so I can take out an x. The smallest exponent is at 2, so I'm actually going to end up factoring out a 2x squared. Factoring out a 2x squared, 4x cubed divided by 2x squared. Well, 4 divided by 2 is 2. X cubed divided by x squared is x. 2x squared times 2x will give me that 4x cubed back. If I factor a 2x squared out of 2x squared, remember, we have to have something there to represent. So if I took 2x squared times 1, that gives me my 2x squared back. Let's look at the second pair. I have a negative 2x and a negative 1. Well, what do 2x and 1 have in common? Absolutely nothing. Well, if nothing, then you can always factor out a 1. Okay? Well, in this case, though, my leading term of my second pair is negative. So I'm not factoring out a positive 1. I'm going to factor out a negative 1. And by factoring a negative 1 out of negative 2x minus 1, I'm going to be left with 2x plus 1. Now I have it set up. I have two terms. Both of these terms have something in common. And that something that they both have in common is 2x plus 1. And if I factor out a 2x plus 1, think about putting your hand over those two terms and seeing what's left. I'm left with 2x squared minus 1. And those are examples of factoring by grouping. Let's move on. Factoring trinomials. Several tricks going on in factoring trinomials, and these are all set up with that leading coefficient not being a 1. You know, I got a 4 and a 6 and a 2 and a 16. So we have to pay attention to what's going on here. So here's how this factoring goes. Again, first step is always look at the problem, say, can I factor anything out of them? So in part A, I've got a 4y squared, a negative 11y, and a 6. There is nothing other than 1 that goes into all three of those. All right, so since nothing goes into all three of them, what I want to do is I want to look at the first coefficient and the last, my constant. 4 times 6. Well, 4 times 6 is 24. I need to ask myself, I need to find out two numbers that have a product. That means if I multiply these two numbers together, I get 24. But keeping those same two numbers, I want to be able to combine them, so get a sum of my middle term, which is negative 11. So we start thinking about numbers that I multiply together and get 24, which is positive, but when I combine them, I get negative. Well, there's only two ways to multiply two numbers together and get a positive answer. If I took a positive times a positive, I can get a positive, or a negative times a negative will get me a positive. So I know that the signs of the two numbers have to be the same. However, how do I add two numbers together and get a negative answer? Well, there's several ways to do it, but based on what I know about the product, I know that if I took two positive numbers and added them together, I'm not going to get negative 11. So I know that the two numbers that I'm going to have to use are negative. Some of you might already see the answer, but let's think about the ways to get 24 with both numbers being negative. I could take negative 1 times negative 24. Multiply it together, I get 24, but when I add those together, I get negative 25, so I don't want that. How about negative 2 and negative 12? Well, negative 2 times negative 12 is also 24, but negative 2 plus negative 12 is negative 14. I want negative 11. How about negative 3? Negative 3 times negative 8. Negative 3 times negative 8 is positive 24. Negative 3 combined or added to negative 11. So folks, this negative 3 and negative 8 is the combination of numbers that I need to rewrite this problem. So what I'm going to do now is rewrite that problem of 4y squared minus 11y plus 6. And the way I'm going to do it is I'm going to use this negative 3 and negative 8 and break this negative 11 into two pieces. Instead of writing negative 11y, I'm going to write negative 3y and negative 8y. Now the question comes, which comes first, the negative 3 or the negative 8? And the answer is simple, it doesn't matter. So either one. So to rewrite that polynomial, y squared minus 3y minus 8y plus 6. And if you'll notice, if you combine like terms, you're going to get back to the problem we started with. Okay, so I chose to write it that way, and again, it doesn't matter if we're negative 3 first or the negative 8 first. We're going to end up with the exact same answer. Okay? All right, factor by grouping. My first two terms, 4y squared and negative 3y. Well, 4 and negative 3, there's nothing that goes into both of those, but both terms do have a y in it, so I'll factor out a y. If I take a y out, I'm left with 4y minus 3. How about the next two? I have a negative 8y and a 6. Well, they don't both have a y, so I can't take a y out. However, negative 8 and 6 are both even, so I can take a 2 out. Now again, I look at that first term, which happens to be a negative 8, and because it's negative, I'm not going to factor out a 2, I'm going to take out a negative 2, minus 2. Well, if I take a negative 2 out of negative 8y, that leaves me with a positive 4y. And if I take a negative 2 out of a positive 6, that leaves me with a negative 3. And just like the previous screen when we're talking about factoring by grouping, I have two terms here. Both of these terms have a 4y minus 3 that I can factor out. And if I covered up that 4y minus 3 on both terms, you would see a y minus 2 left behind. And that is the final answer. Part B, 6p squared minus 7p plus minus 5. as I look at part B, again, we have to ask ourselves, can I factor out a greatest common factor? And in this case, again, there is no greatest common factor. So let's look, this is a quadratic. Let's look at the first term and the last term. Multiply those numbers together. I have a 6 times negative 5. 6 times negative 5 is negative 30. So I want a product that equals negative 30. So to multiply two numbers together to get a negative answer, that tells me that one number is positive and one number is negative. But when I add them together, when I combine them, when I sum them, I want negative 7. So to multiply two numbers together and get negative 30, one's positive and one's negative, to add those same two numbers together and get a negative answer, that tells me that the bigger number has to be negative. So again, if I started with the basic numbers, obviously 1 times 30. But one has to be negative, and we've already determined the bigger number is the one that has to be negative. So if I took 1 times negative 30, that would get me negative 30. But if I combined 1 and negative 30, I get negative 29, not negative 7, so that one doesn't work. Let's go with 2. 2 and negative 15. 2 times negative 15 is negative 30. 2 combined with negative 15 is negative 13. Didn't work. Let's try 3. 3 times negative 10. 3 times negative 10 is negative 30. 3 combined with a negative 10 is negative 7. Those are the numbers that I need, so I don't need to keep going and keep trying different numbers to see what works. So just like I did in problem A, when I separated the negative 11y into the negative 3y and the negative 8y, I'm now going to break up this negative 7p into a 3p and a negative 10p. If you recall, we've had several problems where the second one was negative. So we had this negative 8y here. Well, here I have a situation, and I told you that when you break up that middle term, it doesn't matter which number you write first. My recommendation is if you have a choice, write the negative one down first. That makes the second one positive. That way you're not factoring out a negative number, and that kind of makes life a little easier. So instead of writing this as 6p squared plus 3p minus 10p, I'm going to do the negative one first. Let me change colors here since the problems are so close together. So 6p squared minus 10p plus 3p minus 5. And again, if you'll notice, if you take these two middle terms and add them together, negative 10p plus 3p is negative 7p. So all I've done is change the way I write the problem. I didn't change the value of that. Okay, first pair. 6p squared minus 10p. What do they have in common? Well, I can take a 2 out of both of those. I can take a p out of both of those. So since I can take a 2 and a p out of both of those, let's divide both terms. 6p squared divided by 2p would be 3p. Minus 10p divided by 2p is minus 5. Okay, so I factored a 2p out of the first pair. How about the second pair? What can I take out of that? Well, 3p and a minus 5 have absolutely nothing in common. So there's nothing you can factor out. But if you'll notice, that is a 3p minus 5, which I've already seen one up on the screen. So because you can factor out nothing, you can always factor out a 1. So I'm going to put a plus 1 here. And by factoring out a 1, obviously, all I have to do is multiply 1 by 3p minus 5 to get 3p minus 5. Now I have two terms. Looking at those two terms, they both have a 3p minus 5 in common, so I'll factor out a 3p minus 5. After factoring those out, you can see that I have 2p plus 1 left. And I want to point out when I'm factoring stuff out, when I factored out that 3p minus 5, notice that I'm multiplying 3p minus 5 times 2p plus 1. I've seen people try to put a sign in between there, and that's not right. Because notice this 3p minus 5 is multiplied by the 2p. Notice this 3p minus 5 is multiplied by the 1. Okay? So the final answer is those two binomials multiplied together. All right, part C. 2x squared plus 13x minus 18. Do they have anything in common? No. So because they have nothing in common, just like I've done on the previous two problems, we'll look at the coefficient of the quadratic term, which is 2. We'll look at the constant, which is negative 18. And 2 times negative 18 is negative 36. I need two numbers who have a product multiplied together of negative 36. But when I add them together, when I take the sum of those exact same two numbers, I get this 13 here. So again, just like the last problem, to multiply two numbers together and get a negative answer, one's positive and one's negative. To add those same two numbers together and get a positive answer, the bigger number in this case has to be positive. So because that middle term is a positive 13, I know the bigger number, to get the multiple of negative 36, that bigger number has to be positive. So again, I'll start with 1. Well, 1 times 36. But again, remember the bigger number has to be positive, which means the smaller number is negative. So negative 1 times 36 is negative 36, but negative 1 plus 36 is 35, not 13. Let's try negative 2. Negative 2 times 18. Negative 2 times 18 is negative 36. Negative 2 plus 18 is negative 16. Again, a positive 16. Again, I'm wanting a positive 13. Let's try negative 3. Negative 3 times 12. Negative 3 times 12 is negative 36. Negative 3 plus 12 is 9. Folks, this isn't looking good. Let's try negative 4. Negative 4 times positive 9. Negative 4 times positive 9 is negative 36. Negative 4 plus 9 is 5. Still not 13. And I think you probably see by now we got a problem. The only one left is negative 6 and 6. But those are the same, so there's no way. Guys, this isn't going to happen. There are no two numbers that I can multiply together and get negative 36, but when I add them together, I get that middle term of 13. So because this is not possible, we would actually say that this guy is prime, meaning it does not factor. Kind of like the number 17. The only way to get 17 is 1 times 17. There's no other way. So 17 is prime, okay? So we can have prime polynomials just like we have prime numbers. Okay, last problem for factoring trinomials. 16y cubed plus 24y squared minus 16y. Again, first step of factoring is always, always, always look for that greatest common factor. Well, if you'll notice, all three of these terms have a y. So I know for sure I can take out a y. All three of those terms are even, so I know I can take out a 2. And if you look closer, you can go even further than that. 8 goes into 16. 8 goes into 24. 8 goes into negative 16. So the greatest common factor of this polynomial is 8y. So I will start by factoring out an 8y. If I take an 8y out of 16y cubed, I'm left with 2. 2 times 8 is 16. Y squared. Y squared times y is y cubed. If I take an 8y out of a positive 24y squared, I'm left with a positive 3. 8 times 3 is 24. And y times y is y squared. If I take an 8y out of a negative 16y, I have a negative 2. 8 times negative 2 is negative 16. Y, I don't need another one, so I'm not going to put another y on there. And there we go. I factored out an 8y. But we always have to ask ourselves at every step in factoring, am I done? Okay? So let's look at this trinomial. You know, does it factor? Well, let's see. It's a quadratic. My first coefficient is 2. My constant is negative 2. So 2 times negative 2 is negative 4. So is it possible to multiply two numbers together and get a negative 4, but when I add them together, let me rewrite this. Okay, so I want a product of negative 4, but when I add them together, a sum, I want a sum of the middle one. Now, guys, we're talking about the 3 now because we factored the 8y out. I don't care about that 24 up top. I want to know about this 3. Can I get a sum of a positive 3? Well, to multiply two numbers together and get a negative 4, one number is positive, one number is negative. However, to take those same two numbers and add them together and get a positive 3, that tells me that the bigger of the two numbers must be positive. So how do we get negative 4? Well, 1 times 4. Now, to get a negative 4, 1 has to be negative. But to get a sum of 3, the bigger number, in this case is the 4, it has to be positive. So that gives me a negative 1. So let's check that. Negative 1 times 4 is negative 4. Negative 1 plus 4 is 3. Well, by golly, there it is. So I'm not done factoring. Now, this 8y does not go away. We have to keep this 8y. So I'm going to keep the 8y. I'm going to rewrite this trinomial, breaking up the 3y into a negative y and a positive 4y. So 2y squared minus y plus 4y minus 2. So again, we're going to keep going. We've got to keep this 8y. What do 2y squared and minus y have in common? Well, I can take a y out of that. If I take a y out, I'm left with 2y minus 1. And the last two terms, what do 4y minus 2 have in common? Well, I can take out a 2. And if I take out a 2, I'm left with 2y minus 1. Now, I still have to keep that 8y, and if you'll notice on the inside, both of those terms have a 2y minus 1. So, 8y times, take out that 2y minus 1. If I cover up or take out that 2y minus 1, you'll see we still have a y plus 2. So, y plus 2. Okay? And it's factored completely. Moving on. It's possible that we have perfect square trinomials. Guys, I've been doing this for a long time, and I will honestly tell you that I don't always recognize this pattern. But if you recognize this pattern, you're going to see that this guy factors easily. Okay? So if you see a pattern where you have x squared plus 2xy plus y squared, that's going to factor into x plus y squared. And remember that x plus y squared simply means x plus y times x plus y. If, however, that middle term is negative and it looks like x squared minus 2xy plus y squared, it will factor into x minus y squared. And just like adding, x minus y squared simply means the same thing as x minus y times x minus y. It's just a different way of writing it. A little bit shorter. So if you're the lazy type, you don't want to write x minus y times x minus y, you would write x minus y squared. Examples. First term, letter A here. 16p squared minus 40pq plus 25q squared. As with any factoring problem, the first thing you want to ask yourself is, can I factor anything out? Do they all have anything in common? Well, in this case, the answer is no. But if we look at this, it's kind of interesting. Notice that this first term 16p squared is a perfect square. 16p squared is the same thing as 4p times 4p, or 4p squared. That's kind of interesting. How about the last guy? 25q squared. 25q squared is also a perfect square. 25q squared comes from 5q times 5q, or 5q squared. That's kind of interesting. How about that middle guy? Well, check this out. If I took that 4p, which is my x, and I took that 5q, which is y, if I multiplied 4p times 5q, 4p times 5q, what do we get? Well, 4 times 5 is 20, and p times q is pq. So if you go back to that formula, let's look at it again. It tells us if we have a quadratic in the form x squared plus, oh, there's a 2 there. Oh, there's a 2 there. So anyway, you have x squared, xy, y squared, but that middle term is multiplied by 2. Let's go back. If you'll notice, you could multiply 20p cubed by 2 and you get negative 40. So this would factor into 4p minus, because it's subtraction in the middle here, 5q squared. And again, that's if you notice the pattern, you'll be able to do this. Okay? How about the last one? 36x squared y squared plus 84xy plus 49. Do all three of those terms have anything in common? No. Well, that first term looks like a perfect square. That first term looks like it came from 6xy squared, because 6 times 6 is 36, x times x is x squared, y times y is y squared. And that last term, that 49, looks like that came from 7 squared. 7 times 7 is 49. Well, what would happen if we multiplied those together? 6xy times 7. Well, that's going to be 42xy, which again, just like on the previous problem, 42xy is half of that. So this is also a perfect square trinomial. Our x, based on the formula, is 6xy. Our y, based on the formula, is 7. So I would write this as, and again, the middle term is positive, so we have 6xy plus, because the middle term is positive, 7 squared. And it's factored completely. And again, folks, this is going to come down to, do you recognize it? Did you notice that the first and last term of that trinomial were perfect squares? Did you notice if you took the square root of the first term and the square root of the last term, multiplied by 2, you get the middle term? If you see it, great. If you don't, just work through it, just like we did on trinomials earlier in this lesson. Here are 3 very, very important formulas. If you see a binomial means 2 terms. So everything we've done so far, we did grouping, which required more than 3 terms. We did perfect square trinomials. We did basic trinomials. Now we're going to look at factoring binomials. And there's 3 special binomials to look for. There's 2 perfect squares that are subtracted. There's 2 perfect cubes that are subtracted. There's 2 perfect cubes that are added. Notice something I did not say. There is no way to factor 2 perfect squares that are added. So these are the only things we can do. We can do a difference, which means subtracting 2 perfect squares. We can do a difference, again, which is subtracting 2 perfect cubes. Or we can actually find the sum, or adding 2 perfect cubes. But again, do not try to factor a difference of 2 perfect squares, because it does not factor. And this is the formula to use. So when you're looking at these, and when we go through the examples, it'll make more sense. Right now it's probably a bunch of gibberish on the screen. If we see a binomial, again, 2 terms, we're going to ask, is it squares or is it cubes? And if it is, which formula do we use? I do want to point out, if you'll notice on the difference in sum of two cubes, that each of these areas right here are exactly the same. Both of them have an x, they both have a y, they both have an x squared, they both have an xy, they both have a y squared. The differences in these two happen to be the first signs and the second signs. All right? And what we're going to use to remember that is the word SOAP. So when you factor these, know that that first guy is going to be the same. So if I'm doing a difference of cubes, then that first sign is negative. If I'm doing a sum of cubes, that first sign is positive. The second sign is always opposite. If I'm doing a subtract, a difference of cubes, that second term is going to have a plus. If I'm adding two cubes, that second sign is going to be a minus. And this last sign is always plus. So we have same sign, opposite sign, and always plus. All right? So that's going to help you out remembering these. Let me go ahead and throw this out here. Any test that we take in this class, you're going to be able to use your calculator. You're also going to be able to use a cheat sheet. And a cheat sheet consists of a standard 8.5 by 11 sheet of paper, and you can write anything you want on both sides of that paper. All right? So things like this, if it's going to be beneficial to you to write this on your cheat sheet for that test, go ahead and write it down. I don't expect you to have all this memorized. It helps if you have it memorized. You can work faster. You only have a certain amount of time to take a test, but you can make a cheat sheet. All right, so here we go. Letter A. I see two terms. It's a binomial. I'm subtracting, so it's a difference of something. Is 4m squared a perfect square? Yes. 4m squared is a perfect square. It comes from 2m squared. Minus, is 9 a perfect square? Yes, 9 is a perfect square. It comes from 3 squared. So if we know that formula of x squared minus y squared equals, we know this factors into 2m plus 3, 2m minus 3. And folks, we're done factoring. Again, it's just a matter of memorizing those formulas or having them written down where you can get to them quickly and understand what's going on. Part B, 256k to the fourth minus 625m to the fourth. All right, so here we go. Perfect squares. The more perfect squares you know, the better. I always tell people if you'll memorize your perfect squares from 1 to 25, it's going to make life a lot easier. These are both perfect squares. We are subtracting. Therefore, by definition, this is a difference of two squares. 256k to the fourth. That came from 16. Okay, 16 squared. 16 times 16 is 256. K squared. K squared times k squared is k to the fourth. So there you go. 256k to the fourth came from 16k squared. Minus, how about 625? Well, 625 is 25 squared. 25 times 25 is 625. M squared times m squared is m to the fourth. So 256k to the fourth is a perfect square. 625 m to the fourth is a perfect square. We are subtracting. This is the definition of a difference of squares. And this is going to factor into 16k squared plus 25m squared and 16k squared minus 25m squared. And I've said this before, when factoring, always ask yourself, am I done? Okay? I want to point something else out. When I'm doing a difference of squares, I will always write the plus first and then the minus. And the reason is we may or may not be done after this point. Okay? So the first term, 16k squared plus 25m squared. Well, 16k squared is a perfect square. 4k times 4k. 25m squared is a perfect square. 5m times 5m. However, we're adding, so that is a sum of perfect squares. That first piece does not factor, but since I know that I'm using the exact same numbers and the second term is subtracting, I know that second one's going to be a difference of two squares. So I know that that second one, one second, it lost me? All right. So I know that that second piece is going to be able to factor further, but that first one's not. And that's why I write the plus first, because I'm just going to bring it down. So I'm going to bring down that 16k squared plus 25m squared. The second term, I'm not going to write it down like this, like I have been. Let's just look at that. 16k squared, that comes from 4k times 4k. 25m squared, that comes from 5m times 5m. We are subtracting. It's a difference of squares. So it's going to factor into 4k plus 5m times 4k minus 5m. And now we ask ourselves, are we done? The answer is yes. It doesn't factor any further than that. And there's your answer to part B. So it got a little longer, and the reason it got longer is because there was two separate factoring pieces to go to solve this problem. Part C looks ugly. Notice I have an a plus 2b that's squared, and also notice I have a 4c squared. Well, 4c squared comes from 2c squared. So 4c squared is a perfect square, and obviously a plus 2b is a perfect square. And we're subtracting, so this is in fact a difference of squares. So it comes down to a plus 2b plus 2c times a plus 2b minus 2c. And that does not factor any further. And that's a good thing, we ran out of space anyway. Part D, what do we see there? Sums and differences of cubes. X cubed, that's a perfect cube. That comes from x times x times x. Plus 27. Okay, a while ago I said it's a good idea to know your perfect squares through 25. It's a good idea to know your perfect cubes up to at least 6. Okay, 27 happens to be 3 times 3 times 3, right? So 27 is the same thing as saying 3 cubed. So looking at that formula for a sum of cubes, we know that this factors. It factors into the first guy, same sign, so plus, because this is a plus problem here. So there's my x plus y times x squared, opposite sign. These two guys multiplied together, x times 3, so 3x, always plus the last guy squared. 3 times 3 is 9. Okay? Now, a lot of times a person is going to factor this, and they're going to look at that last term of x squared minus 3x plus 9 and go, oh, but does that factor? And the answer to that is no. If it did, then we wouldn't have, let me go back 2 slides. If that did factor, then we wouldn't have this formula here to find the sum and differences of cubes. Okay? And notice that what I did was I applied this formula right here. I found out what my first guy cubed was, my second guy cubed was, and I wrote the answer. The first guy plus the second guy, the first guy squared minus the product of the two, always plus the last guy squared. And that's exactly what I did. And again, it's just a matter of writing those formulas down or memorizing them, doing enough practice to understand what's going on. The second one, I am subtracting, so this is a difference. The first term is m cubed, so I am cubing the m. minus, what number cubed is 64? Well, that's 4. 4 times 4 is 16. 16 times 4 is 64. So what do I cube to get 64n cubed? And that would be 4n. I'm going to cube that. So m, using that formula, m is my x. Using that formula, 4n is my y. So how does this factor? Well, it factors into x, which is m. Same sign, negative. Y, which is 4n. Times x squared, so m squared. Opposite sign, so plus x times y, so m times 4n, that would be 4mn, always plus y squared. My y is 4n. 4n squared would be 16n squared. All right, last one. I'm going to bring this guy down. 8q to the 6th plus 125 p to the 9th. Well, 8 is a perfect cube. It's 2 cubed. 2 times 2 times 2 is 8. Q to the 6th is a perfect cube because it's q squared times q squared times q squared. So 8q to the 6th came from 2q squared. All of that's cubed. Plus 125. 125 is a perfect cube. 5 times 5 is 25 times another 5, that gives you 125. And p to the 9th comes from p cubed times p cubed times p cubed. So doing that, this is my x, this is my y. My x is 2q squared, and my y is 5p cubed. Now let's apply that formula. Well, the formula tells me that the sum of 2 cubes is x, which is 2q squared. Same sign, so plus y. My y is 5p cubed, so 5p cubed, times x squared, which means 2q squared squared. So if I square 2q squared, 2 times 2 is 4. And q squared squared would be q to the 4th. Opposite sign, I'm going to take my x and my y and multiply them together. So 2q squared times 5p cubed, that would be 10p cubed q squared. Okay, running out of space here. Let's see if I take it. I don't remember how to move it, so I'm just going to move over to the next line. I'm still writing here. I'm just going to move it to the next line, okay? My last piece of this is going to be y squared. Well, my y is 5p cubed. Well, and it's going to be always plus. So plus 5 squared is 25. P cubed squared would be p to the 6th. And so there's the answer to part C. All right. And here's just 3 problems to factor. It doesn't say anything about what types they are. It's just a matter of factoring them. On the first one, what we have here is, we're doing substitution. If you'll notice, this first one has something that's squared and the same something that's to the first power in the middle. Basically what we're saying here is, let's just say that x is the same thing as this 2a minus 1. Well, if that's true, if I took x squared, wouldn't that be 2a minus 1 squared? So what I'm going to do is rewrite this problem, but instead of writing this 2a minus 1 stuff, I'm going to replace those with x's. Well, 2a minus 1 squared is the same thing as x squared. So I have 10x squared minus 19. 2a minus 1 is the same thing as x minus 15. And if you'll notice, that problem right there is a lot simpler than what that original problem looks like. And what we're going to do here is we're going to factor it just like we did on problems earlier on in tonight's lesson. And when we get done, we're going to have x's. But remember, our original problem does not have x's in it. So we're going to have to go back and substitute the 2a minus 1 back in for x. Okay, so 10, 19, 15, can't factor anything out of this. So I'm going to look at 10 times negative 15, and that's going to be negative 150. So I want two numbers that have a product, meaning I multiply them together and get negative 150. But when I add them together, I get that middle term of negative 19. Well, now I know that to do this, to multiply two numbers together and get a negative answer, one's positive, one's negative. And because the sum is negative, that tells me that the bigger number is going to be negative. So we're taking that negative 150 and we're dividing it by an x numerous times, and we're looking for the numbers that we need. So it looks to me, I'm using the calculator real quick to see what they were. It looks like 6 and 25, negative 25. 6 times negative 25 is negative 150. 6 plus negative 25 is negative 19. So those are my two numbers. So this is going to be 10x squared minus 25x plus 6x. So again, I took that middle term, and instead of writing negative 19x, I broke it up into two pieces because, if you'll notice, negative 25x plus 6x is 19. And again, I wrote down the negative one first because it makes life a little simpler, minus 15. Okay. First two terms, I can take a 5 out. First two terms, I can take an x out, leave me with 5x minus 5. Second term, that's 2x minus 5. Okay, take out first two terms, take out 5x. I'm left with 2x. 5 times 2 is 10. Minus 5. 5 times negative 5 is negative 25. Second two terms, I can take out a 3, leaving me with a 2x minus 5. Factoring that, bring it over here. I have 2x minus 5 times 5x plus 3. Okay, so I factored that original problem, but instead of 2a minus 1, I factored it in terms of x's. Now that I'm done to this stage, I can't go any further. I have to go back and say, but wait a second, there's no x's in that original problem. So the original problem, x, is really 2a minus 1. So what I really have here is 2 times, here's my x, but x is 2a minus 1 minus 5 times 5 times 2a minus 1 plus 3. Distributing that 2, 4a minus 2 minus 5 times 10a minus 5 plus 3. So I distributed the 2 to the 2a, distributed the 2 to the minus 1, and that's where the 4a minus 2 came in. But I still had that minus 5 that's kind of going along for a ride. On the other side, I took 5 times 2a and got 10a. 5 times minus 1 got minus 5. And this plus 3 goes along for a ride. And now if you'll notice, I can combine like terms here. So I have 4a minus 7 times 10a 2a minus 2. And that is finally the final answer. Okay. Part B, that is a sum of cubes. And it's nice that I still have the 2a minus 1. So I'm going to still let 2a minus 1 and x be the same thing. So I have x cubed plus 8, which means I have x cubed plus 2 cubed. So I know that that factors into x same sign y times x squared opposite sign x times y, always plus y squared. But remember, that's not my answer. I'm going to have to go back and change those x's to 2a minus 1. Okay, so there's one x right there. This x is being squared, so I'm going to put it in parentheses, 2a minus 1 squared, so there's that x, minus 2 times 2a minus 1, there's that x, plus 4. And folks, this has to be simplified even further. Okay, this video is quite long already. Be more than happy to come back and do another video to show that. The last one, we're going to factor that, but basically what we're going to do is factor it in terms of z squared. So if I was to write that and say, well, x equals z squared, which means x squared equals z to the 4th. So that would be 6x squared minus 13x minus 5. And we'll just go on to factoring that. And once you find that final answer, change those x's back to z squares and simplify. All right, folks, a lot going on in this factoring thing. We're going to see this throughout the semester.